Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So today I'd like to welcome each and every one of us to my channel, and also I'd like to thank each and every one of us personally for engaging us on the comment section and also for subscribing to our channel. I'd like also to request our members to also continuously engage us on the comment section, and also check on our various playlists that I've put on our description boxes so that we can be able to view other contents which are maybe related to topics in physics, chemistry, mathematics, or biology. So today we're going to look at a very interesting work of one of the French physicists by the name Charles Augustin Coulomb. Of course, this is going to play a role in collaboration with other laws, which are going to assist us, of course, describe different aspects for electricity and magnetism. So for today, we're going to just have a review of various aspects of the Coulomb's law. And of course, we shall look at different ways in which we're going to represent various aspects of the Coulomb's law, both in formula and perhaps, or rather what we can refer to as a mathematical representation in form of expressions or equations. So in this sense, of course, I'm going to look at the aspect of basically what we have referred to as Coulomb's law. So as I can say, of course, we have looked at various ways in which we can be able to represent principles, laws, theories, and other aspects. In this case, of course, for the aspect of what we refer to as laws, basically entails statements that describes observations or what we refer to as occurrences in nature that appear to have some, of course, aspect which is can be presumed or rather can be ascertained to be true. And therefore, we're going to look at the relationship between this Coulomb's law and other analogous laws like the gravitational law that I'm going to give in form of perhaps an equation. So in this case, Coulomb's law is a law that, of course, tries to find the relationship between a force that is acting between charged particles. So in this sense, I'm going to use this specific illustration to show those particular charged particles that are being separated by a distance that I can be able to give in form of d. So therefore, this one for illustration purposes, I'm going to refer to this one as q for charge for 1 and 2. And therefore, the separation distance between these two charges, Q1 and Q2, of course, are going to be illustrated as such. In this case, Coulomb's law tried to establish the relationship in terms of forces which are acting on these specific two charges. Now, later we're going to see that the works of other scientists like Michael Faraday and Robert Milcan, of course, is going to provide some of the clues on specifically the interaction of charges, which are like, in this sense, of course, we are going to refer to as the aspect of charge, and therefore this is going to be explicitly positive and negative charges. So therefore, this is going to give a relationship between the relationship between the interaction of forces which, of course, are acting on charges which are like charges, either positively charged or charges which are negatively charged in that particular aspect. So therefore, the relationship that is going to be established between these two charges is going to be given by Coulomb's law. And this law states that the forces between two charged particles, which of course this sensor can be able to presume to be electrical spheres, which are at rest, is going to be inversely proportional to the square of the distance which I've provided, d, which is the distance between them. And this particular aspect, we're going to consider the distance from the center of this particular charge to this particular center, which is going to, of course, entail d. Now, in this specific respect, we're going to consider the charges being experienced by q, or rather, which is contained in q1 to be uniform to the one that is contained in q2, and therefore that is going to give us the proportionality that we were talking about of the distance being, or rather the force being inversely proportional to the square of the distance between them. But we're going to see that this particular force is going to be directly proportional to the product of the amount of these two charges. So therefore, I'm going to give that specific statement that I've said, which is Coulomb's law in terms of an equation, which is going to assist us, of course, understand further figuratively how we can be able to describe that specific aspect. So therefore, I've said that Coulomb's law states that the force which is experienced of course, by two small charged spheres. Of course, it's going to be inversely proportional to the square of the distance between them. Now, in my particular case, I've given d to, of course, refer to the distance between the two. I can give an arbitrary, perhaps alphabetical letter to represent that in a small case. So in this case, I'm going to use the letter E to represent this R, of course, to represent this distance between the two spheres. Now I can just give an illustration, quick illustration for the same. So this is going to be this is Q1, Q2. This is the distance from center to center between the two. And the force that I'm going to use, of course, is going to be represented using F. And therefore, that is going to give the relationship between that force and the distance. And of course, I've talked about the concept of a charge, which is going to be represented using Q. So therefore, from this one, I can develop a relationship using those specific letters of what I've referred to as Coulomb's law, which states that the force between two small charged electric spheres at rest is going to be inversely proportional to the square of the distance between these two electric spheres which are uniformly charged. And of course, we have also seen that it's going to be directly proportional to the product of the charges. So if I indicate this one and say that this is going to be directly proportional to the product of the charges, this is going to imply this one. So in any case, if I consider it of course, a combination of the distance between them and the charges, therefore, this proportionality is going to be given such a kind of a relationship. And therefore, I can be able to write this one in terms of an equation and write the forces which is acting between two charged spheres, of course, can be represented as K, the product of the charges, and then inversely proportional to the square of the distance between them. So this specific letter for K that I've indicated in this particular sense represents the constant of course, the proportionality constant, which is going to be given as 4 pi epsilon naught. So we're going to see those specific, of course, constants being applied repeatedly in some of the videos that we're going to, of course, learn, whereby, of course, I can just indicate this one. This is going to refer to what we call as electric permittivity. So this is going to be electric permittivity. And sometimes in some of our videos, we're going to look at the concept of permittivity constant and others. This is pi, of course, which appears in some of our videos. This is a constant also. So that is the implication of that. So this basically is going to refer to what we call as Coulomb's law, which is going to be applied every in electricity and magnetism and some aspect of electrostatics that I've mentioned in this specific case. So catch us in our next video where we're going to look at a different aspect of Coulomb's law and some of the related laws that I've talked about, like the gravitational law and others, which of course are going to be analogous to this. So that is it for now, guys. Hope that we have understood how we can be able to represent Coulomb's law in terms of force and the charges and then the distance between them. And basically this specific proportionality constant that I've referred to as K in this specific aspect. So bye for now. Kindly subscribe to our videos for more and engage us on the comment section. And also kindly check on our description boxes for various links to other playlists, which of course contain different videos in mathematics and the sciences. So that is it for now, guys. Bye. God bless you.